Well, hello there, and welcome to another episode of The Making of Pokemon Gemini. In this episode, we're going to get back to some more tile-based functions. I know, it's been a few of those, but don't worry because I believe this is the last set of functional tiles we're ever going to have to worry about, at least for the time being. So, I've mentioned it in my previous episodes what we're going to be doing. We have tiles for the collisions. We have tiles for the regions, so that you go from, say, Pallet Town to Route 1. The tiles can mark that. And now we're going to create tiles for different types of terrain. And this is important in Pokemon especially for a couple of reasons. The first one is pretty simple, is water. So you can't walk on water, but you can't surf on land. So you need to know what's what for that. But more importantly, and the thing that most of these tiles are going to be used for, is that different types of terrain give you different encounters, different Pokemon encounters. So what I'm going to do is I'm only going to be making tiles for water, and then for the two different types of water, which is water and shoreline, and then for each type of different encounter site. Anywhere that you can walk normally that doesn't have an encounter isn't going to need a tile, because I don't want to have to fill the entire room with tiles if we don't need it to be that way. That's just going to be inefficient and slow to design. So that leaves us with a few different types of terrain, and let's jot them down. So we have water, we have shorelines, because if you didn't know, even from the original generation of Pokemon, if you surf on the shore, you actually get different encounters than if you surf out in the water. So we have to mark the differences. So we have water, shoreline, we have grass, obviously. We have double battle grass, which will hopefully be a thing. I'm going to try to make it a thing, and if not, if it doesn't work out, I can always remove it later. But for now, we'll plan on having double battle grass. We have caves, and we have indoor encounter tiles. So there are most indoor buildings in the game, you can't encounter anything. But occasionally you'll get some special building or whatever where you go inside, and inside the building you can encounter stuff. And so for that I want to have its own tile. So for instance, the abandoned power factory in the first generation of games, and then also the I almost wanted to say Silphco, but Lavender Tower with the ghosts. So there are cases where you want to be inside a building and still have encounters. So we want a tile for that. So it's 1, 2, 3, 4, 5, 6. I believe that's all of them. Let's see. Grass, double battle grass, shore, water, cave, and indoors. I can't think of another type of terrain where you would encounter anything or that affects your motion or anything. So I think this is all. So we just need to create a tile set with 6 tiles, and we already know how to do that. So let's come into sprites. Where did I keep this? Oh no, sorry, backgrounds. Little rusty. So we have region tiles, collision tiles. So we'll just create a new background and call it terrain tiles. Edit this. So the first thing I'm going to do is resize it down to 16 by 16, and then resize it again just so I don't have to do math, and make it 600, no, not 600 pixels, sorry, 600%, so that we have room for 6 tiles. All right, and then basically each one of these little spots is 1 tile, so we just fill them in. So I'm going to be giving them some very, very basic symbolic art on each one, so that when I go to design these levels, I can look at it and say, oh, that's obviously a grass tile. With all the other tile sets, with the region tiles, which region is which doesn't really mean anything except in the context of each room, so those are just colors. With the collision tiles, we used basic, it's hard to see with the grid on there, but we used those lines to see which sides were solid. But with this, each tile represents a different type of terrain. So And that's going to be important within each region. So we want to make sure that we know which tile is which terrain. So we're just going to do some basic symbolic stuff. So for instance, let's make this bigger. If we start with grass, oops, that's a white background. Let's fix that. And oh man, I forgot how. Okay. So each one's 2 by 2. You know what? Let's zoom. Let's see, view, no zoom. There you go. So let's start by making a regular grass encounter or regular grass terrain type. Let's make it the full 16 by 16. And then now we can zoom in, and now we know how many tiles each one is, right? So this one, we're going to give it a little bit of symbolism as a single battle grass as an S, right? So it's S and kind of wavy like a thing. Like I said, I'm not an artist, but you know, it is what it is. Oh. Okay, so that's single battle grass. We can tell what it is. So then we have double battle grass, which I'm going to make the opposite colors because in the game double battle grass is dark. So we're going to make this dark as well, or I should say in the actual Pokemon games. So let's, oh man, that tooltip's getting in my way. Like that, but then there's a little pixel or two on this side. I'm trying to have precise motion with the trackpad. There we go. I think that worked, right? Well. That's fine. Okay, and then this is double battle grass, so we can either do a D or 2 S's, because I'm going to do 2 S's because they're not actually supposed to be S's, they're grass. So this way you can see single battle, double battle. We had water. I wish I could, is there a way to have a set size on this? No. All right, well, so for water, we will do a blue. Let's do a light blue so it's not too dark. I think I'm actually a pixel off over there, so I'll fix that in a second. So we'll take eyedropper for that color, and we'll add one more little pixel over here. Okay, and it looks like that's probably the case over here as well, is that I missed some pixels, so let's fix that. And then so for water, I think blue just on its own is good, but just in case, we'll add some like waves or something. Right, so if we zoom out, yeah, you could tell that's water, right? I think so. I think it's good enough, because remember, the player's not going to see these. They're going to be hidden immediately. This is just for function. And the only reason I'm even putting any symbols on it is so that when I build the levels, I can tell which is which. So I think that's good. So now we need the shoreline, which, I don't know, what color should the shoreline be? That's too similar. Let's make the shoreline the dark blue, right? I think the other one was also a pixel off, or this one is. Oh man, it's so hard to tell. Let's see, if I make this a 16 by 16 tile set, where does that fall? Yeah, I think the blue needs to be pushed over by 1 pixel. The dark blue, that is. So let's just draw in a line of pixels here. And again, it doesn't have to be perfect. The game's going to know what they are. It's just a matter of us, you know, it looking nice when we build our levels for us as a designer. But so this is the shoreline. So I'm going to use a little bit of green, I think, to have it be blue and green, as in water and land. I don't know. Makes sense to me. And that's a shoreline, so we'll do like a grass. So it's blue with grass is the shore. And then we just have cave and indoors, right? Grass, shoreline, water, double battle. Yep, caves and indoors. For caves, I'm going to use like a brown color. That's not really brown, is it? Yeah, it's good enough. So for caves, I'm going to use this. I think that's too thin, so I think it's actually a pixel off on the other one. What's new? So we add a pixel to here, and actually the more I look at it, the more I think that's actually gray, but I have a program called Flux running, which makes my screen less blue at night, because it's better for your eyes, but I think that's messing up the colors here. But it is the middle of the night, so I don't want to turn it off. So, that'll be fine. So this will be a cave, and for a cave, we'll do kind of a yellowish, like, mountain peak. I know mountains and caves are two different things, but they kind of feel associated. So a little mountain peak for a cave. And then the last one is indoors, which will be very easy because we can just make it as in like tile floor, right? So we'll just do like a black and white checkerboard for that. I can't get that end, I don't know why. Oh, it's because it's not exactly a... You know what? This will be good enough. It's not going to be a perfect checkerboard, but whatever. It just has to get the point across and be 16 pixels total. So if I do this and fill in that. There you go. And that one I don't think we need to give any symbol on top of, because I think the fact that it's a checkerboard is symbolic enough. So there we go. We have our terrain tiles. All right. So now we have to make a terrain manager to handle detecting which type of terrain we're in, right? So we'll create an object, terrain manager, and I think I actually want to give this some methods, because we're going to want other things to be able to talk to the terrain manager and ask like what kind of terrain we're on and do different things. And so the terrain manager, actually, do we need this? Yeah, I think we should keep it separate just for organization. So we have the terrain manager. It is callable. And so like the region manager, we'll call the parent and set up our methods. So in our create event, we call the parent, and then we set up our methods. This doesn't matter. And so I believe it's just called methods, right? Yeah, methods, and then the actual name of the method. So what kind of methods are we in? I think we only need one, right? Which is get method, or get, yeah, get terrain. And that will be index 0. And I think we are going to want to do one more thing here. So let me remind myself how the character's motion was. I think we're going to want to move some of the collision code into the terrain manager, because things like detecting walls and stuff is one thing, but also when you have stuff like water, right, you can't just make that solid because you can surf on water, but you still have to not be able to walk onto it. So that's kind of quasi-collision, but it's based on the terrain type of whether it's water or not. So I think I may want to move some of the collision code into the terrain manager, or at least put some extra code. Um, okay, so we have go to X and go to Y, right? And that is what changes which way we move and all of that. So if we were to, after we detect whether you can walk there based on normal collision, if we were to ask the terrain manager if there's water at the goal, and if there is, then we just reset that and don't move, I think would be the way to go. But I guess, oh yeah, excellent. So I think that's probably the best way to do it. So let's get started on the actual code then. So we have the get terrain. We don't need to move any collision code into the terrain manager because it'll be able to tell us what type of terrain is there. I think we need to give it, we don't need this. I think we need to give it a map to map the terrain indexes to types. So let's look at our terrain tiles so that we can keep their order in mind. So I don't know. Terrain types is a map. Now this is not going to be from external files just because these are, I don't think, going to change very much, and there's only going to be 6 of them. So this can be hard-coded. So we have, well, actually, we don't need a map. It can just be a list. Do we need a list, or can it just be an array? Yeah, I think this works better as an array. So terrain types 0 equals grass. Terrain types 1 equals double grass, and so on and so forth. So in many programming languages, if you have an array, you have to declare it first. So you'd have to do something like terrain types equals that, or equals new array, or equals array, or whatever else. You might have to do terrain types equals something. You don't have to do that in GameMaker. However, you do have to do them separately. I think I'm actually going to take this quick second to make a short little helper script to create arrays faster. Just because we're probably going to need to use quite a few arrays in this game, and instead of having to type them out one by one, I think we can do it better this way. So we'll just call this array, because that is not a keyword. We'll say for I equals 1. No. What do I want to do? Okay, so we're going to have a return array, which I'm just going to call ret, and then starting with 0 through to argument count. So it's going to go through all the arguments and then set ret I to argument I. So it's basically just going to argument I. So it's basically just going to copy all the arguments into an array and then return it. So return ret. And this works because in GameMaker, arrays are their own type, and you can actually transfer them around like all together instead of just one at a time. So we're copying it over into that. Now, it would be nice if I could just return the argument array, but I'm pretty sure that doesn't work because that array is very local. And technically this is local too, but when you return it, it stops that from breaking. Whereas the argument array disappears after this script goes out of scope, which means once the script finishes, that array is gone, so you can't actually use it anywhere. So if we copy that over into this one and then return it, it should keep it in scope and we should be able to use it. So what that allows us to do is we could say terrain types equals array, and now we can just put them all in here. So we could say grass, double grass, water, shore, cave, and indoor, I guess. Do you want to call it indoors or building? I think indoor is fine. So 1, 2, 3, 4, 5, 6. There you go. And so these are in the same order as this, which is important. Because now, if I look up, say, tile 3, 0, 1, 2, 3, then it'll be 0, 1, 2, 3, and it'll be the shore, and that does, in fact, match with the tile. So then our user event 0, user defined event 0, is our method. So this is where we will return the proper type. And so all we have to do, first things first, we want to make sure that our tiles, we have a new layer, not at that depth. 999, so we'll make a new one layer above, and that layer, 9999 or 8, whatever it is, I copied it. That's where we're going to put all our terrain tiles. So tile equals tile layer find at that depth. And I believe the way I set it up was that I could do that for my methods. It's been a while since I've looked at my method code, but I think that was it. So we can pass in 2 arguments for the X and Y position. It'll find the tile, and say if tile exists, else retval. Was it called retval or returnval? Like I said, I don't remember these methods. Return value is what it's called. So return value equals unknown with a question mark, so that it very much is clear that it was an issue, that there was no tile there. Actually, no, you know what I'll do? The ret value will be none. So if it doesn't find a tile, then that is an area where, that shouldn't be an error. It's just an area where you can walk, but there's no encounters. And so I think just returning none should work for that. And so now we have to, if it did find a tile, one of these tiles, we have to decide on which tile it was, or figure out which tile it was. So x, or index, equals tile get left of tile divided by 16, and then rounded down. And that should give us the index, and then we can just say return value equals, what did I call it? Terrain map? Terrain types. There we go. So the return value is the value of terrain types at our index. So that should be it. And a quick way to test this is to take our region manager, this has x, x, y, y. All right, so we can take our region manager, and we'll add a little bit of code here just for a quick second, and call it terrain, which is, it'll start out as none, and then terrain equals terrain, call method. Did I not? Oh, call method. And we'll call it on the terrain manager. And it'll be called, it was called get terrain, right? Let's just make sure I did that right. Get terrain, yep. Get terrain, and we'll pass the arguments as X and Y. You know, the player's X and player's Y. So that'll have our terrain, which means now we can, if we wanted to, draw text string terrain. So this should allow us to see which terrain the game thinks we're in at any given point. We currently don't have any terrain, but if we come down to, oh, it didn't make it. 9998. Oh, because it didn't have any tiles on it, so GameMaker just immediately deleted it. But now we are going to add some tiles. So let's say we have some single battle grass right here, and beyond here is a cave. Obviously it's not, but we're going to pretend it is. And for now we're going to leave the tiles visible, just so we can debug. And if all works, we should be able to hide the tiles, and everything should still work properly. Hopefully. And we immediately crash. Why? Why do we crash? Unable to find any instance. Oh, it would help, you know, if I actually put the terrain manager into our world here. So we'll make the terrain manager persistent, and we will put one of them in the world. Managers, terrain manager, put that one right there. Yeah. Okay, so let's try it again. Now that the terrain manager is in the world, we should be able to, it should work pretty well. Okay, so we've got our little demo room. It says none on the corner right here because we're not in a terrain type, but if we go here, it says grass, none, grass, cave, 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 cave. None. Good. Okay, so our terrain manager works. And so what I'm going to do is I'm going to take this tile hiding code in a room start event, and I'm just going to copy it over and put it in our terrain manager, because our terrain manager is going to do everything, or most things at least, regarding terrain. So if we put our, where's the room start? There it is. So if we have our terrain manager hide the terrain tiles, it makes more sense. So that should hide the terrain tiles at the beginning of each room, which is great. So now we can get rid of that debug code. We don't actually need to know the terrain at every step. We only need to know when we need to trigger battles. And that is what we're going to do next. So we don't actually have a battle system yet. So we're not going to actually trigger a battle. But we are going to sort of do the code that will sort of decide when to trigger a battle and what to trigger a battle with, and make sure that that works. And then the next episode, we'll actually start working on the battle system, which is going to be really exciting. So I'm looking forward to that. But we can't get there quite yet until this part is done. So all of that is good. So now we need to start actually dealing with battle calculations. So somewhere here, capture calcs, battle calcs? Is it actually in battle calcs? No, this is in battle. Where did I put that? I'm trying to find where I put the, did I not? Okay, I don't think I actually wrote down the battle calculations on like how to determine when to start a battle. So I'm going to quickly look those up right now. I know how to do the math based on our weighting that we had before to decide which battle should start. But I need to know um, when a battle should start. So every time you take a step, there's a chance of triggering a battle if you're in some kind of terrain that has encounters. But I don't remember exactly how to determine when that happens. So Pokemon calculations encounter, I guess. So remember in one of the other episodes, the last episode, I said that a lot of programming is debugging. Well, a lot of it is research as well. So we're going to research this. Uh, Wild encounters. So this is the Pokemon Essentials wiki. So Pokemon Essentials is sort of a library of stuff, assets, and code and stuff to make Pokemon fan games in RPG Maker, I believe. So, I mean, we're not using that, but I believe it should explain how encounters work. So, encounters.txt, this is which encounters there are, probability of encounter. Each encounter type must have a specific, no. Percentages. But that just tells you what's the chances of each type of encounter. How do you determine whether there's an encounter or not? $60, $70, $80, $90, $100. Yeah, because if this was all it did, if these were the only numbers it used, then it would be 100% chance of encountering something, right? But how do you actually determine whether an encounter occurs? Okay. Pokemon determine when an encounter occurs. Let's see if that's a thing. Random encounter. It's for all kinds of games, not just Pokemon. Wild Pokemon. Oh, wait, there it is. Dang. Let me just see if it's in here. In the games. Tall grass, caves, buildings, surfing. Deep sand, puddles, and snow. Not sure if we're going to have that in the game, but if we are, we can always add tiles to our tile set and our map. Other stuff, blah, 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 blah. Let's see. When encountered, okay. There are several ways to alter the wild encounter rate, like repel. Cleanse tag lowers the encounter rate. But what is the default encounter rate? Okay, so this doesn't tell us, but I did see this. What is the percent chance of a random encounter each time you enter a patch of grass? So according to this, it's 1 in X, where X is, or 1 in 187.5 over X per step, where X is the weight. But we're doing the weighting differently. So, but that doesn't, yeah, and I know I've seen this link before. It doesn't actually show the explanation anymore because they have Poke Radar. And we're not going to be using the Poke Radar, but maybe it tells you about it. Only can be used in tall grass. Nope. This doesn't really tell you. That's for the probability of a shiny. No. But according to this, it's this formula here, which is the only formula we found so far, so I think it's a good start. The problem is 1 in 187.5 divided by x. So that would mean 187.5. So you'd pick a random number between 0 and this value. And if that number is 0 or 1, let's say, if it's just one of those numbers to check against, then you get the encounter. So does it just every step go through the encounter, all of these possible encounters, and then it does this formula, and whichever one hits, if any of them hit, you get that encounter? Because then that would be, so 187.5. So for a very rare Pokemon, you pick a random number between 0 and 150. And if it's 0, then you get the rare encounter. So you have a 1 in 150 chance. So out of every 150 steps in grass, basically, you would get a very rare encounter. Whereas for the rare encounter, 187.5 over 3.33, it's only a 1 in 56 chance. So no, that doesn't make any sense, because the more common ones would be, oh, no, yeah, 1 in 56 is a better chance than 1 in 150. Yes, that is correct. My math didn't work out for a second, but that's, yeah. Okay. So you know what? We're going to go with that formula, because it's the only formula that we found. So 1 in 187.5 over x. Except we don't have categories for our version of Pokemon. We have weights. Which makes it a little more difficult to utilize this, because, well, if we just divide it by the weight, so what we could do is replace this x and these values with the actual weight of our Pokemon encounters. So a Pokemon encounter with a weight of 1 would have a 1 in 187.5 chance of encountering. And you would do it twice, but that would actually make the next Pokemon's chances lower. What's a better way to do this? All right, so straying from the sort of potentially default Pokemon way of doing this, I think because we're using weights and not these special like categories with their magic numbers assigned to them, I think we might want to do this a different way. So determining which encounter you get is going to be done based on the weights. But to determine whether there is a counter or an encounter, I think... Okay. So what if we inject a little bit of realism into this? Just a little bit. And base it on how many encounter types there are. So, Overworld. Or actually, I think this one would be in the Region Manager. Actually, do we want it in the Region Manager or the Terrain Manager? I feel like this should be in the Terrain Manager. So, methods get encounter, and that equals, that's index 1. And so we'll create a user-defined event 1, which is our get encounter. So let's call it get encounter. And this is going to take information from the region manager, though. So the region manager holds all of our region data, including our battles, but we have grass battles. So I think instead of having it like this, I think we want to rearrange some of our data for the sake of simplicity. Don't worry about that, or that. Okay, so we had before our data with grass encounters, water encounters, fishing encounters, cave encounters, etc. I think if we turn these encounters into a map, it would be easier to reference them. So for instance, we'd say encounters, and we'd make that a map, or an object, or a dictionary, or whatever you want to call it. And then we'd have inside that grass. And our grass would be would contain what we currently have for our grass encounters, right? So we'll cut that out and put it up here, right? And then, well, let's tab these over for clarity. Right? And then we do the same thing for all the other types. So we have water, which is this right here. And then we'll have fishing as its own thing, which is not based on type, terrain type, but that's okay. So we can just have fishing here. And I think because fishing is the odd one out, not being based on the terrain, I want to keep that last. And then we put cave encounters up here. So what I'm doing, well, let's copy the cave encounters. Well, there are none here, so that's fine. Okay, so what I'm doing here is I'm rearranging the data so that our encounters are going to be in this map. And the reason for that is the terrain manager returns the type of terrain as a string. Like it'll say grass or water or whatever. So if we have the encounters as a map like this, then we can get that string and then just use it to look up the list of encounters from this map, rather than having to convert like grass into grass encounters and fishing into fishing encounters, right? This way they're all already, in the map under the same name that the terrain manager is going to return to us. So I think that's fine. Let me just make sure I didn't have any missing things. I think that works. And so then we'll do the same thing here. So encounters. So our grass encounters are empty in here. Our water encounters, though, they exist. So water exists as that with our magic carp. Fishing, well, cave, there is no cave. And then fishing equals this. And we don't need that comma. So we can close or delete this and paste, oops, fishing equals that. Get rid of that. Okay. So by having it like this, we should be able to look up our encounters easier. And as always, because of sandboxing, we need to re-import our data into our game. And there was actually, I found an extension to sort of break the sandboxing so that I would be able to access files without having to import them like this. But that ended up actually not being a good choice because it was Windows only, which means if I used it, the entire game could be Windows only. And I'd like to be able to export it to multiple platforms if possible. So instead, I'm just going to continue. Nope, not an extension. Instead, I'm just going to continue with this method of keeping it imported like this. And so now that we've rearranged our data, our region manager, when it loads the region, it's going to have to change some stuff. So instead of grass battles, we're going to have encounters starting out as undefined. And then it loads the battle, or yeah, it loads the region here. Regions, load regions. So where does it? So it just puts the region map in there. So where do, so I have grass battles here. Oh, every time you go into a new region. So instead of grass battles being region grass battles, we just have encounters being region encounters. And by doing this, now our encounters will actually be a map filled with all the different types of encounters instead of having to separate them by terrain type, which means we can look up information. So for instance, we have our get encounter, right? So the first thing we want to do is make sure we're in a region that has been loaded and has its encounters loaded. So to do that, all we have to do is if region manager encounters, and we can, I think we should be able to just say equals undefined, then we exit. But just in case, I believe there's also a function is undefined there. And that's probably the better way to do it than comparing against a special type like that. It should work either way, but just for safety, I want to do it this way. So if the encounters list is undefined, then we exit. Oh, and that's another thing. So our region manager should actually no. Our region manager actually needs to, okay, so region, global region map, region ID. So so when the room ends, we want to destroy that region map just for the sake of, oh wait, no, do we? Oh yeah, we reload it anyway. You know what? We'll do that when we start a room. We'll say if, what does global region data start at? Basically, I need to figure out if there was a previous region, global region map. Yeah. So we say if global region map. Oh man. I guess because it starts out as a list, we can just say if ds list empty. So if the list is not empty, then a previous region was loaded, and then we can do ds list destroy global region map. But I think we want to go one step further than that. Because right now we have this JSON decoding into a big map, and we're just skipping it to the default, but the map itself still exists. And if we don't clean that up, then every time we load a region, it's just going to be a new map in memory. And even after we clean up what's inside, the map itself is going to stick around. So we're going to get a bit of a memory leak if we do it that way. So what I want to do is call this cleanup. And then the region map will be set to the default value or the default key in cleanup. So that way, what we can do is take if that is not undefined, then ds map destroy global region map cleanup, and then set it to undefined. Right? So what that'll do is it'll clean up all of the memory associated with the region map when we load a new region. That way we don't have tons of regions like piling up in memory. So that's just to keep things from causing a memory leak. And then in our initialization, we should also set that to undefined. Oh, excuse me, undefined to begin with. So that's just some cleanup. So now we work on the actual encounters. Ooh, it's already an hour in. So this should be the last thing we do today. So we have get encounters, and now this has encounters set, right? So now we have encounters as a map. So when we call terrain manager get encounter, what we want to do is we want to say type equals call method, not this, self, or just to be safe, ID. So if you do self, it's a keyword that refers to this thing, but it actually is a value that gets interpreted as meaning this. And I'm not quite sure how scoping works with that. So just for safety, I'm going to pass in the ID of this object or the instance of the terrain manager. I'm going to call get terrain at arguments 0, arguments 1. Oh, that could actually be a problem. Well, no, because we're just getting the x and y, right? So that's fine. I was going to say it's going to be a problem because when I call this method, it's going to overwrite these arguments in this instance because we're calling a method from this instance. But actually, we don't need to do that. We don't need to do it that way. We can just say get. We can just say event user 0 because it's within this. So we can just call that, and it already has the arguments, as you would expect, because this method is being called with those arguments. So that should be fine. So by doing that, we'll have return value. So type equals return value. And now we should be able to look it up in the map. So we have region manager encounters. So now we say if ds map exists, region manager encounters of the type specified, then we will look up one of them. Okay, so now we will have encounter list equals ds map, or sorry, we can just do it this way, region manager encounters type. So now we have a list of our encounters, and for each one there is a species, a level, and a chance. So what we want to do is sort them by chance, I believe. And then we can just pick a random number between 0 and the total of all of their chances, and then keep adding their chances until we've surpassed that number, and then whichever Pokemon we were on or encounter we were on, when we surpassed our random number is the value we'll get, right? I don't know if that made sense when I say it, but it'll make sense once I code it. Luckily, I believe when I first started, yeah. So I have a quicksort custom, And that is going to allow me to do this. It's going to allow me to sort things by a custom property. So I want to copy that list. Well, I guess it doesn't matter if I sort it, right? So does quicksort custom return nothing, just source list? Okay, it's in place. Just going to sort the list, which is our encounter list. We start at 0. We end at the size of the list because we want to sort the entire thing. -1 because that's how indexes work. And then our script is going to be not a basic comparator. It's going to be sort by weight, right? So then we're going to create a script here called sort by weight. And I'm doing it camel case instead of underscore just because it is a comparator. And so this way I can tell the difference. I don't think it really is a big deal. But the idea here, so if we look at our basic comparator that just sorts two numbers, we subtract the first from the second, and based on what this returns, that'll tell quicksort which order to put them in. So if the first is greater than the second, it'll be positive. If the first is less than the second, it'll be negative, and otherwise it'll be 0. Which means if it, so this will sort it in ascending order. It should return negative, yeah. I didn't actually make a note of whether it's ascending or descending, but I think it's ascending, which is exactly what we want. So all we really have to do for sort by weight is argument 0 weight, or is it, did I call it weight or chance? Chance. Argument 0 chance minus argument 1 chance. So that should sort the list in ascending order. And then once we have them sorted in ascending order, now all we have to do is start picking our random numbers. So we first need to find the sum. So we'll do sum equals 0, and then we do for I equals 0, I is less than ds list size encounter list. So we go through the entire list, and then we just say sum plus equals encounter list I chance. Oh, it does not allow you to chain lookups like that. So we will separate them. We'll say encounter. So we'll say encounter equals that, and then sum plus equals encounter chance. Okay, so now we'll have our total, right? And so now we pick a random number, RNG, between 0 and the number, right? Or should it be 1 and the number? I think it should be 1 and then set it to less than or equal. No, it'll be 0 and the number. So we'll pick a random integer between 0 and the sum. Does that include the sum? That is the question. So irandom 0 to 9 inclusive. Okay, so it will use both. Should it ever be able to hit the sum? No. So we'll do sum minus 1. All right, so yeah. So now all we have to do is go through our list again and keep doing the same thing with a check value, except except what we want to do is we have our check, and then as soon as our check value is greater than our RNG, greater than or equal to? No. If it's greater than our RNG, then we return, we can't do return, but return value equals our encounter. So it'll actually return the encounter and then break the loop. However, if there is no encounter of the type, then we would have, but return value is going to be set here. So we'll do return value equals undefined if there are no encounters loaded. But even if there are encounters loaded, if there is none of the right type, we should set it to equal undefined at the end here as well. I just want to make sure that this can't break so that this doesn't ever find an encounter. Like if you have an encounter of 1, 2, and 3, that's a total of 6. So the sum is 6. You'll pick a number between 0 and 5. And as you start adding them up, in the end, you'll at least get to a sum of 6, which is greater than 5. And so you're always guaranteed to find an encounter this way. So that should give us an encounter. So now all we have to do is decide when to actually run our encounters and everything. And I think I want to do it in the player. Because the player actually does its steps. So I think if I put it just right here, then every frame that you're not moving is going to have a chance to trigger an encounter, and I don't think I like that. Oh, and I didn't actually put in the water tile here. So we are going to put a quick thing in here. So we're going to have the player say is surfing false, and then later we'll allow him to surf. But for now, we're just going to say if. So we'll say var dest terrain, so destination terrain, equals call method terrain manager get terrain at go to x, go to y. So that is our destination terrain. So we can say if destination terrain equals water, or destination terrain equals shore, and we are not surfing, then we say go to x equals x, go to y equals y, image index equals 0, image speed equals 0. And then we can say else for if we are surfing, to make sure we don't surf on land, which is if it does not equal water and it does not equal shore, and you are surfing. And so in this case, we don't actually need those brackets. Okay, so that is that. But now, where do we actually want to? It's when you take a step. So what we can do is, I think we want to put it here. So there moved equals false, but then if we did that, moved equals true, and if we moved vertically, so that's if we moved horizontally, here's if we moved vertically. Oh, oops, I can't put, that's an else, which has to be attached to the if statement above. I missed that. So moved up here. This is another long episode, isn't it? Yep. And so then we'll say moved equals true, moved equals true, and now we know that we have moved. And so if moved and x equals go to x and y equals go to y. So what this means is that we've moved this frame, but we're now at our destination, which means we've arrived at our destination this frame. And so for that, this is where we will do some trigger encounters. So if we just do get encounter, well, so what was our math? It was, oh yeah, I wanted to inject a little bit of realism into this. And so the number of encounters in the area should change, should impact how likely it is that you get an encounter, right? So if there's more animals in the area, you're more likely to run into something, right? So if we use that, so we can say, first we need to know what type of terrain it is to get the encounter map. So actually we'll just, no, that just picks a, yeah. So what we'll do is we'll pick a wild encounter every time, and then whether or not, once we do the math to see whether you get an encounter, if that turns out to be false, we'll just discard the result. I think that's the easiest way, so we don't have to keep looking stuff up from the map. We don't have to look up the terrain type, then the map, and then look up an encounter if we need to, which then looks up the terrain type in the map again. And map lookups shouldn't be, the math that we're doing, the map lookups, shouldn't be very intensive, shouldn't be inefficient. So, so we'll do encounter, and that was just called get encounter, right? Yeah, get encounter. So equals call method terrain manager get encounter at go to x, go to y. Now I could just use x and y here because they're equal, but I feel like using the destination just in case. I don't know why. Shouldn't matter. So now we've gotten a random encounter, assuming it's not undefined. So if encounter, so if not is undefined encounter, now we just have to do the math. So, I guess we still have to look up. You know what? Let's not do the realism thing, because if we use the number of encounters in the area to determine whether you get an encounter, then we're getting an encounter here, but then we have to look up the encounters list again, which means we still have to look up twice as many things every frame, which is not good. So instead, what if we just make it at like a 10% encounter rate, right? Or 0.5%? If we make it like a 1 in 200 chance, right? So that's 0.5%. I think every 200, no. Okay, let's make it 1 in 150. So then that way every 150 steps or so, you should get into a battle. So then if I random between 0 and 150, or I guess because 0 is counted, 0 and 149, so that there are 150 possibilities. And if that equals 1, it could be any number we're checking against for the same probability, but I'm going to go with 1. So now we say, do we have a draw event on this thing? No. So I'm going to add a draw event here. And again, this part is just for debugging. So we're going to call it draw encounter is nothing. And now we're going to draw self and then draw text draw encounter. And so all we're going to do is draw the name of the encounter. So draw encounter equals encounter species, because that was what we called it in the map. So yeah. And then else draw encounter equals none. Okay. So, fingers crossed, when we go to our Route 1 cave, we don't have cave. We have Route 1 grass. We don't have any cave encounters. So, in our demo room, we'll just throw some grass onto Route 1, because there's no Route 1, there's no Pallet Town grass encounters, and there's no Route 1 cave encounters. So, we'll come into our tiles, come down to 9998, which is our terrain tiles, and we'll throw some grass. Actually, just delete these. Make a little patch of grass right there. So that is our single battle grass. And if I walk around in there, we should see the name of a Pokemon kind of appear and occasionally change up at the top of our oh, I can't see where it is though. Oh, encounter list doesn't exist in Quicksort Custom. Oh, we're calling Quicksort Custom for encounter. Oh, there you go. See, that doesn't say encounter list. That says InnoCunter list. That would be the problem. So let's fix that. That's just a typo. No big deal. Encounter list. Encounter list. There we go. I hope I spelled it right, because clearly I have trouble typing that word. Encounter. I don't know why. But if this works, this will be the end of the episode. If it doesn't, we'll continue debugging till it does work, and then we'll end the episode. Actually, what I want to do, just for the sake of debugging, is I'm going to not hide the tiles so that I can see where I'm walking. Because again, we're going to have aesthetic tiles on top of these so that we'll actually be able to see the grass and stuff. But I haven't gotten there yet. That's just art. So, yeah. Okay. So if we come over here, oh, and now we have an error again. DS list find value argument 1 incorrect type expecting a number. Okay. So line 20 of our quick sort, we're executing the comparator. So this J is not a number? Line 20. I thought I had this all working from before, but apparently not. J is low, J is less than high. So low, these are indexes, and sort by weight turns the chance minus the chance, which are numbers. And our terrain manager is calling that zero and size minus 1. That's interesting. Okay, so to debug this, because I'm not calling ds_list_find_value, but this is shorthand for that. So, and if it's in this line, this is the only place that's used. So I'm going to go with if j is not real, real being a real number or a number, then show message j is not real. J is, and we will see what the value is. So it'll show that message before it crashes if it is not a number, because that's what it's telling me is that that's not a number, which it should be. So we'll find out why in a second. Crash. It did not pop up. Interesting. Still says argument 1 incorrect type expecting a number in ds_list_find_value. How is that? It said it's a number on line 23. Oh, that's 23. I'm confused. Or is script, yeah, it is. Index, argument 0, argument 1. But if it's not a number, then this should be true, that it's not a number. What the actual heck is going on here? All right, so this is something I have to debug another time, probably in between episodes. But what's important here is if we just order everything here in ascending order, so 1 and then 5, which is fine, 1, this one's not, so we'll put these in ascending order. Then we don't have to sort it, and so then we can remove the sort, that one line that sorts it, and test out the actual encounter code, because this is just a bug with my quick sort, apparently. Chance 1, chance 1. Okay, so everything is now sorted in ascending order. So let's re-import the data. Now in practice, I do want to fix that bug, because when I'm making these region maps, and whoever's helping me is making these region maps, it would be kind of annoying to have to make sure that everything's in ascending order, because it'd be so easy to accidentally put a higher chance first and then a lower chance, and that would break the encounter code. So I don't want that. But for now, we will just comment out our quick sort here. We'll do fix me quick sort crashes saying iterator j is not a number, question mark. So I'll leave that as a note for me. And so in case you didn't know, things like fix me and to do are common sort of comment shorthands, because what it allows you to do is I can come in here, I can do search in scripts and include scripts in all functions and everything, and I could say case sensitive, look for fix me. Excuse me. And now if I search, I found that, and I can go straight to that code, right? And so that lets me do that for as many things as I need fixed, so that at any point I can just see, okay, what are the bugs that need fixing that I haven't gotten to yet? And then I can go back and work on them. So I'm going to do that for now. And again, I'll work on that between episodes. Because you had a whole episode of debugging last episode. You don't need to see me debug. But hopefully, without sorting, now that it's sorted by default in the data itself, it shouldn't crash. Okay. So I'm walking around here. I'm not seeing anything change. I'm not seeing anything written. Okay, so that could be a bit of a problem, because it doesn't look like it's actually getting anything. Okay, so let's see what's happening. It's not crashing though, which is good. But what can I do? So when we call get encounter, which we know is being called because it was crashing with our quicksort, it should have this. So I'm going to say show message JSON encode encounter, right? So basically, it should now pop up a message. Oh, and then let's go through all the possible chances here, or all the possible kind of events. We know that it's not stopping here because it got to this line. So whatever is happening, it's happening below this line. So this is where it actually goes to get our value. Oh, huh. Okay, I see what's happening. So even if we get a value, we break out of this loop, but then the code continues and the return value equals undefined. So no matter what, it's going to return undefined. There's a couple of ways to fix this, and I think what I'm going to do is just put this in an else, and I can actually get rid of that. I'm going to leave that, but just comment it out because I don't think it's needed. I think we should see it work now. But if it doesn't work, I'll just uncomment that and throw in a couple of more messages and see what pops up. But here we go. So there it is. Okay. None, 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 none. Okay, so we are getting nones, but we're not getting values. So the code is triggering, but they're all being set to none. Maybe I just haven't walked around enough. Maybe the chances are too low. No, I feel like this is not a chance issue. This is not a probability issue. It's just constantly none. Okay, so we go back to our code. The encounter being none happens not in here. The encounter being none happens in the player, so now that, that is an, so if it's undefined, we'll say draw encounter, see, I can't type, encounter equals no such encounter, whereas here we'll say no such luck. So we'll know what's causing the ultimate thing. So it is a, you know what, for now, for testing, let's bump the chances up. Instead of 1 out of 150, we'll make it 1 out of 50, or 49, that's 0 to 49, so it's 1 in 50 chance. So hopefully we should see it more often. I really didn't think that it was a probability issue, but we can find out by testing it with a much higher probability. No such encounter. I mean, there's also no such luck. Okay, so when we're out here, there's no encounters for no terrain types. When we're here, it's just saying no such luck the entire time. It's a 1 in 50 chance. That seems like it would be enough. But it's like constantly no such luck. I don't understand that. There it is. I got a Pidgey. Okay, so 1 in 50 is still a pretty low chance, apparently. I kind of expected it to be higher, but it seemed to work. So let's make it a 1 in 10 chance. I don't want it to be 1 in 10, because I feel like that's every 10 steps. Maybe 1 in 20. We'll call it 1 in 20. And then there was another thing that I noticed which was, what did I notice? No, I think that's it. So 1 in 10, or sorry, 1 in 20 chance. See, on average, you would think that would be every 20 steps, which kind of seems like it's a lot. But it was seeming slow. Maybe it's just because it's just this little patch of grass, and in an actual game it'll be different, but we can always change that probability later. No such luck. Rattata. I just ran into a Rattata. So if we move around here, how often do we actually get Pidgey? Okay, so I think that's decent. The point is, it's getting Rattatas and it's getting Pidgeys, and if we look at our Route 1 grass encounters, we have Pidgeys and we have Rattatas. So it is able to get both of them. Now, whether it's actually getting them at the same rate, we'll see. So far it's been 50-50. We should get more Rattatas than Pidgeys if everything is going well, but it is still random, so there is an element of luck to this. So it won't necessarily be like Rattata every time. We just have to keep testing, I guess. I just want to see one more encounter. That's another Pidgey. Seems like we're getting them at 50-50. There's a Rattata. All right. It is a long episode. Wow. Okay, that is a very long episode. Sorry for the long episode, but there you go. We now have encounters working, which means in the next episode we can start working on the battle system that will trigger from these encounters, which is going to be great because that means we can finally start bringing in some of the sprites made by Zach, and I also have another sprite artist who is working on some stuff. I haven't. I'm still kind of waiting on him. But we still have the stuff from Zach that I showed you in a previous episode. So we'll get those sprites in and we'll start working on the battle system. And that's going to be really fun because that means we can start working on changing our encounters to our actually fake mon instead of the real ones. It means we can start adding in moves, which is going to be an interesting thing. You'll see why. And yeah, so that's pretty much it for this episode. No such luck. Oh boy. Until next time, keep looking for wild encounters.